Nobody on Earth saw it happen. No camera caught the flash, no astronaut, no satellite. No telescope was pointed at the exact right patch of gray lunar dust at the exact right second. And yet, in the early morning hours of August 5th, 2026, a 4-ton chunk of American rocket hardware slammed into the far side of the moon at roughly 5,400 miles an hour. And somewhere on that ancient, airless surface, a brand new crater exists right now that did not exist the day before. This is not a movie. This is not a simulation. This actually happened days ago, and most people have no idea it even occurred, let alone what it means, or why this isn't even the first time something almost exactly like this has happened before, under circumstances that turned out to be far stranger than anyone initially realized. Here's the full story, and here's why it matters more than a single piece of space junk should. Let's rewind to where this object actually came from, because the backstory matters. On January 15th, 2025, a SpaceX Falcon 9 rocket lifted off from Cape Canaveral, Florida, carrying not one but 2 separate lunar landers stacked together on the same launch. One belonged to a company called Firefly Aerospace and carried a spacecraft named Blue Ghost. The other belonged to a Japanese company called ispace and carried a lander named Resilience. Both were private missions, part of a new wave of commercial companies attempting something that, until fairly recently, only national space agencies had ever pulled off, landing a spacecraft softly on the moon. The Falcon 9's upper stage did exactly what it was built to do. It carried both landers most of the way to the moon, released them onto their own trajectories, and then, its job finished, became nothing more than 40 feet of empty aluminum tubing drifting through space with no further purpose and no planned destination. Both landers went on to make history in very different ways. Blue Ghost successfully touched down in early March of 2025. Becoming the first fully private spacecraft to ever achieve a soft landing on the lunar surface, a genuine milestone for commercial spaceflight after years of failed attempts by other private ventures. It spent roughly 2 weeks operating on the surface, deploying instruments, capturing imagery, and even recording a total solar eclipse from the moon's perspective as the Earth passed directly between the lander and the sun, before eventually powering down as designed once the long lunar night set in. Resilience, unfortunately, did not share that success. It attempted its own landing roughly 2 months later, and something went wrong in the final stretch of descent, likely a sensor or altitude miscalculation, and the spacecraft came down too hard, ending the mission in a crash rather than a landing. But this story isn't really about either of those landers, or about which one succeeded and which one didn't. It's about the empty rocket stage that carried both of them most of the way there and then simply kept going, because nobody had given it anywhere else to go. For the better part of a year and a half after that launch, this spent rocket body drifted through space in what engineers call an uncontrolled state, meaning nobody on the ground was actively steering it or managing its path. It wasn't lost exactly. Space tracking experts, including independent astronomers who specialize in following exactly this kind of debris, kept an eye on it the entire time. But it also wasn't going anywhere useful. It was simply looping through space, subject to the same forces that govern every object with no engine and no fuel left to correct its course. The gravity of the Earth, the gravity of the moon, and even the faint but constant pressure of sunlight itself, slowly nudging its trajectory over months and years in ways that are almost impossible to predict with total precision that far in advance. It's worth understanding just how little it actually takes to redirect an object like this over a long enough stretch of time. In the vacuum of space, there's no air resistance to slow anything down, no friction quietly correcting a drifting path back toward stability. A rocket stage with no fuel left and no working engine is essentially a passive object being pushed around by whatever gravitational field happens to be strongest at any given moment, plus the faint but very real pressure exerted by sunlight itself hitting its surface. A force so small it's usually irrelevant, but one that adds up meaningfully across months and years of uninterrupted drifting. Every time this particular stage swung close to the moon or close to Earth during its year and a half of wandering, its path bent just slightly, and each of those small bends compounded on top of the last one, slowly narrowing its options until eventually only one destination was left. By the middle of this year, those forces had done what physics eventually does to anything drifting for long enough near a large gravitational body. They pulled it in. SpaceX's own director of NASA's science and Dragon programs, Juliana Scheiman, explained it plainly to reporters covering the story. What happened, in her words, was essentially a mixture of solar activity and gravitational forces, gradually putting the stage on a path directly toward the moon. Nobody commanded it to happen. Nobody at SpaceX pointed this piece of hardware at the lunar surface on purpose. It was simply the slow, inevitable outcome of leaving several tons of metal drifting in space for long enough without a plan for where it should eventually end up. Astronomers who tracked these things did exactly what you'd hope careful scientists would do once a collision looked increasingly certain. They calculated it. One of the key figures in predicting this specific impact is Bill Gray, the creator of widely used astronomy tracking software that specializes in following exactly this kind of orbital debris. Back in April, well before the actual impact, Gray published a detailed report projecting where and roughly when this rocket stage would eventually strike the moon. And on the morning of August 5th, at almost exactly the time and location predicted, it did. The Rocket T stage struck near the moon's western edge, close to two well-known lunar craters named Einstein and Bell, on terrain facing away from where any active spacecraft happened to be orbiting at that precise moment. Because of that timing, and because the impact site sits on a portion of the moon that wasn't in view of any spacecraft capable of capturing it live, nobody actually watched the collision happen in real time. The confirmation came a different way. A telescope in Chile, positioned to observe that stretch of lunar surface, captured what astronomers identified as the debris plume kicked up by the impact, a brief cloud of pulverized lunar dust thrown upward and briefly illuminated by sunlight, before settling back down onto a surface with essentially no atmosphere to disperse it. That plume was enough for space tracking experts to say, with real confidence, that the predicted impact had occurred more or less exactly as calculated. But there's still a piece of proof scientists are waiting on, because a distant flash of dust isn't the same as actually seeing the resulting crater. NASA's Lunar Reconnaissance Orbiter, a spacecraft that has been circling the moon since 2009 and has spent years methodically photographing its surface in extraordinary detail, is now being maneuvered to pass directly over the predicted impact site. When it does, expect it. Within the following week or so, it will capture what scientists call before and after imagery, comparing photographs of that exact patch of lunar terrain taken prior to August 5th against fresh images taken after, to visually confirm the exact size, shape, and location of the crater this rocket stage carved into the moon's surface on impact. Now, here's the part of this story that should genuinely stop you for a second, because it changes how you should think about everything that just happened. This is not the first time a rocket stage has crashed into the moon by accident. And it's not even the first time people initially assumed a wayward piece of space debris slamming into the lunar surface belonged to SpaceX, only for that assumption to turn out to be completely wrong. Rewind back to March 4th, 2022. Astronomers tracking a mysterious piece of space debris designated Danuri 9138 watched it slam into the far side of the moon, carving out an unusual crater that, when later photographed, turned out to have a strange double-lobed shape, essentially two overlapping craters formed by a single impact. At the time, the leading theory among the astronomers tracking the object was that it was the spent upper stage of a SpaceX Falcon 9 rocket, specifically the one that had launched a satellite called Scoviar back in February of 2015. The story spread quickly, under exactly the kind of headline you'd expect. Another SpaceX rocket had struck the moon. Except that as more careful analysis came in over the following months, the story started to fall apart. Researchers went back through the object's orbital history and its behavior in space, and the numbers stopped adding up for a Falcon 9 upper stage. Eventually, astronomers landed on a different, much more specific candidate, the third and uppermost stage of a Chinese Long March 3C rocket, the very same rocket that had launched an uncrewed Chinese lunar mission called Chang'e 5T1 back in October of 2014. China's government initially disputed the identification, but the scientific case kept building. A team of researchers based at the University of Arizona spent months comparing the object's light curve, essentially how its brightness flickered and changed as it tumbled through space, against thousands of computer-simulated possibilities. What they found strengthened the Chinese rocket theory considerably, and by late 2023, the identification had moved from a strong hypothesis to something the researchers described as conclusively confirmed. The object that struck the moon in March of 2022, initially blamed on SpaceX, was in fact a leftover piece of Chinese rocket hardware, one that had apparently been quietly orbiting through cislunar space, the region between Earth and the moon, for nearly 8 years before anyone even noticed it was on a collision course. There's an even stranger detail buried in that same research that's worth mentioning because it never fully got resolved. When the University of Arizona team studied how the object tumbled through space, they found it wasn't wobbling the way you'd expect a simple, roughly balanced rocket body to wobble. It was tumbling end over end in an unusually stable, consistent pattern, the kind of motion you'd expect from an object carrying significant extra mass concentrated at one end, rather than an empty shell with just an engine on one side. Based on that tumbling pattern, researchers estimated the object was carrying a mass roughly balancing out 2 rocket engines weighing more than 1,000 pounds combined. But the publicly disclosed instruments that were supposed to be on that particular Chinese rocket stage only accounted for a small fraction of that mass, something closer to 60 pounds. In other words, the numbers suggested this rocket body may have been carrying additional undisclosed payload mass that has never been officially explained. Nobody's claiming anything sinister here. Space agencies don't always publicize every detail of every mission component. But it remains one of those small, strange, loose threads in the story of the moon's growing collection of accidental scars, a piece of hardware that hit the moon quietly, sat unidentified for over a year, got misattributed to the wrong country's space program, and even after correct identification, still carries a mass discrepancy nobody has fully accounted for. Put those two stories side by side, the confirmed August 2026 SpaceX impact and the misidentified 2022 Chinese impact, and a pattern starts to become obvious. This isn't really about any single rocket, or any single company, or any single country. It's about the fact that the moon has quietly become a dumping ground for humanity's leftover spaceflight hardware. And almost nobody paying attention to the news cycle realizes just how often this is now happening, or how difficult it can be, even for professional astronomers with sophisticated tracking software, to figure out exactly whose leftover hardware they're looking at once it's out there tumbling through the dark for years at a time. And it's not just rocket stages. The list of human-made objects that have ended up crashing into the moon, sometimes deliberately and sometimes very much by accident, has been quietly growing for decades. Back in the 1970s, NASA intentionally dropped the spent third stages of several Saturn V rockets onto the lunar surface, using the resulting impacts to trigger tiny moonquakes that instruments left behind by the Apollo astronauts could measure, helping scientists understand what the moon's interior structure actually looks like. In 2009, NASA deliberately crashed a spent Centaur rocket stage into a permanently shadowed crater near the moon's south pole called Cabeus, specifically to kick up a plume of subsurface material that a following spacecraft, called L-Cross, could fly through and analyze. That mission found something enormously significant: strong evidence of actual water ice buried beneath the lunar surface, a discovery that continues to shape how space agencies think about future lunar bases today. But plenty of lunar impacts have not been deliberate at all, and the list of accidental failures has been growing right alongside the deliberate experiments. India's Chandrayaan-2 lander crashed into the moon's surface in 2019 after a landing attempt went wrong in its final moments. That same year, an Israeli spacecraft called Bereshit also crashed during its own landing attempt, and Bereshit's story carries an unusually strange footnote. The spacecraft was carrying a payload of tardigrades, microscopic organisms famous for their ability to survive extreme conditions, including the vacuum of space itself. Whether any of them technically survived the crash in some dormant state remains an open, slightly unsettling question nobody has been able to answer, since there's no way to go check. In 2023, Russia's Luna 25 mission spun out of control during its approach and also crashed. And because that particular lander carried a small amount of plutonium-238 as part of its power source, that radioactive material is now believed to be sitting somewhere on the lunar surface as well, presumably harmless, given how it's contained, but a permanent addition to the moon's collection of scattered human debris all the same. Here's why all of this matters beyond simple curiosity about a growing pile of space junk. NASA is not treating the moon as a place humanity visits occasionally anymore. Under its Artemis program, the agency is actively planning to build a permanent lunar base and begin sending astronauts on a regular, recurring basis starting later this decade. Not as isolated missions, but as an ongoing presence. And that changes the calculation completely. A rocket stage crashing into some random, unoccupied stretch of the lunar far side is, scientifically speaking, mostly harmless, an interesting data point for astronomers, and not much more. But as more countries and more private companies send more hardware toward the moon, and as NASA and its partners start building permanent infrastructure on the surface, the odds of an uncontrolled piece of space debris eventually coming down somewhere it genuinely shouldn't stop being a distant hypothetical and start becoming a real operational concern. That's exactly why, in the aftermath of this most recent impact, NASA and SpaceX have publicly confirmed they're now in active discussions about how to prevent future uncontrolled lunar impacts like this one from happening again. SpaceX's Sheeman was direct about this when speaking with reporters, stressing that this particular impact was never planned or intended, and that the company is now working with NASA specifically to figure out better ways to manage what happens to a spent rocket stage once its primary mission is complete, rather than simply letting it drift for a year and a half until gravity decides where it ends up. So where does that leave things right now in the days immediately following this impact? Astronomers have their predicted timing and location. A telescope in Chile has its debris plume confirming something did, in fact, happen at almost exactly the calculated moment. NASA's lunar reconnaissance. Orbiter is on its way to get the photographic proof that will let scientists study the new crater directly, measure its size, and compare it against the models used to predict the impact in the first place. And somewhere out there, on a stretch of gray, airless terrain near the craters Einstein and Bell, there now exists a brand new scar on the moon's surface that did not exist a week ago, created by a piece of hardware that carried 2 lunar landers most of the way to their destination, and then simply kept traveling until physics finally decided where its journey would end. The deeper truth sitting underneath this story isn't really about any one company or any one country or even any one rocket. It's that we are still, right now, in the very early and very messy chapter of becoming a species that regularly visits another world, and every messy chapter in any kind of exploration comes with unintended consequences that nobody fully planned for. The moon has no wind, no rain, no weather of any kind capable of softening or erasing what we leave behind. Every crater, every crashed lander, every tumbling rocket stage that eventually comes down stays there, essentially forever, a permanent record of exactly how careful or how careless we were during this specific stretch of history. Right now, that record includes at least 2 confirmed rocket body impacts within the last 4 years alone, 1 Chinese, 1 American, 1 initially, misidentified as the other. And there is nothing stopping that number from growing again the next time somebody launches hardware toward the moon without a clear plan for where it eventually needs to go. If this kind of story is what you come here for, hit subscribe, turn on notifications, and drop a comment letting me know what you think NASA and SpaceX should actually do about all that leftover hardware drifting around up there, because judging by how often this keeps happening, this almost certainly won't be the last time we're covering a story exactly like this one.